In the last video, this workflow took 10 minutes and 5 manual script executions. I automated all 5 into one command and also added some additional features. Copy pasting output into a browser chat works fine for a lab environment. The moment you try to run it against a whole site, you want to run it on a schedule, or you want somebody else to be able to run it for you. If you're not there and you're on PTO, the manual workflow starts to fall apart. Documentation isn't a one-off problem, so the tool that you use to create it shouldn't be either. Running 5 scripts is fine for a proof of concept. Once I saw there was some interest in the manual workflow, collapsing it into a single script was the obvious next step. I want this to be easy to use for your sake and mine. Here's the plan. Inventory file, API key, one command that calls the script, and a finished runbook. As always, the script and example files are in GitHub, and the link will be in the description. Also, as of this week, I spun up the blog subpage on my website, and each long-form video will have an accompanying blog to go with the video that might explain it a little bit better than I can. So feel free to check that out. There'll be a link in the description for that as well. In the last video, we used 5 separate Python scripts to collect, redact, and assemble device output into an AI prompt. Then you had to paste that output into a web browser, whether that's ChatGPT, Claude, or Gemini, and copy the result back out. It worked, but it wasn't necessarily efficient. Let me quickly show you what this original script did. There's 5 steps in the original script. It would collect the data, it would redact the data, it would then assemble the prompt, it would then restore the map.json file back into the runbook that was created, and lastly, it would generate a network diagram for us. You can check this blog out on my site. So let's take a look at what the new script does differently. So again, under the hood, it does all 5 steps still. It collects, it redacts, it assembles. The difference here is it calls an API versus pasting into a chat. It restores, and then you can get your diagram, which is optional. Now, when your manager asks for updated documentation, you're not scrambling to manually update Visio documents, Excel spreadsheets. You point this script at an inventory file, and you hand them an updated runbook and diagram in a fraction of the time. So let's go ahead and set this up. Let's first take a look at our inventory YAML file. So I have this open here, and as you can see, this is a very basic setup. If you don't know YAML, that's okay. Just follow this format. There's example files that I provide in GitHub. Again, you just fill this out with the device name, with the IP address of your device, the type of device that it is, and what the role is. The role determines what commands it runs on that device. So if it's a router, it'll run different commands to generate your runbook versus if it's a switch. Now, don't be overwhelmed if you've never heard of YAML. I'll be honest, I am not a YAML professional by any means. I learned the basics to make this video. It's pretty simple to learn, and YAML is used by Ansible, Docker Compose, Kubernetes. It's worth learning YAML. But again, don't be overwhelmed if you're not sure. Just follow the format here. One thing to note, the script looks for this inventory YAML file, and it needs to be at the same level as the script. So for example, I just have an episode 5 folder for testing for this video. Within that, I have the script and then the inventory YAML file. So you can export this out, fill it out, just make sure that when you run the script that YAML file is sitting in the same directory as the script. My inventory YAML file is just pointing to this lab. So this is just a CML lab running for free as a VM workstation on my machine. Before we go any further, let's talk about API keys. API keys are an additional cost. They're not very expensive for this specifically. I think I loaded $5 onto my Claude API, and I ran this test like 6 or 7 times, and it cost me $1.50. So you unfortunately can't just use your $20 monthly subscription for ChatGPT or Gemini or Claude. This is a separate setup, but you can set up limits on spending, meaning you can load $5 into your account, and you can set it to not auto load so that you don't just blow through tons of money. So we'll head over to Claude's site to generate an API key. It's just console.anthropic, and you'll go to manage API keys. You'll just click create key here in the top right. You'll just name your key. You'll click add, and then here's the API key. I'm going to close this and delete this so that you don't take all my money. And I am just going to be using this key here that I have already generated in the testing. But that's how you'll go create a key if you need to. So next we'll switch back to our WSL instance in VS Code. And we're going to bring up a terminal. We're going to change this to an Ubuntu session. We're already in our working directory, so we're just going to activate our virtual environment real quick. And then here's the command you'll run. I've already run these in my environment, so I'm not going to run these again, but I'll show you on screen. So you'll run this command here. And again, I'll put the commands for this in the description of the video. You're basically going to set your API key as an environment variable. You're going to paste it here. Then you're going to run source bashrc. This essentially just updates the bashrc in your local session. Bashrc is the startup script for WSL. And this just says, hey, we're saving this API key in the startup script of WSL, but I don't feel like restarting WSL. So go ahead and reload the bashrc for me. So that's what this source command does. And then once you have it set, just go ahead and echo it out so that you can make sure that it's set properly. And then you're good to go. This script also supports environment variables, so you can set your device credentials ahead of time and run it on a schedule. It is worth noting that in this lab environment, you can obviously just set these via plain text. However, if you're in a real production environment, it's highly recommended to use a secrets manager. So that handles setup. Now here's the part I think you'll really like. All right, so now we're going to go ahead and run the script, and I already showed you my CML lab so that you know it's running live. This isn't running against just a text file. This is actually connecting to live equipment. We've already activated our virtual environment, so we're good there. And we're just going to simply run the command. This will ask for credentials. We're not using an enable secret in the lab, but you can if you want. And it's connecting to devices. It redacted and assembled already. Now it's just connecting to the Claude API. It's sending the prompt to Claude. As you can see here, the default model is set to Claude Sonnet 4.6. Now I did test this with Opus 4.6 just to see the differences. And to be honest, Sonnet actually handled it better than Opus did, and it's significantly more efficient. So I would recommend using Sonnet for this if you're in the Claude ecosystem. As you can see here, now it finished, so it restored. Pipeline's complete. And we're just going to ls into our output folder so that we can see the new file that was created. And as you can see here, we have a new folder created. This is our timestamp. And we'll go ahead and open it up. I'm going to grab our runbook, and we'll do a Control-Shift-V so this looks better. I reviewed this pretty extensively, and the results are actually better than doing a copy-paste into a chat. So it gives you an overview, your devices. You can see here we have our IP addressing, our devices, the routing summary, trunking table, VTP status, management services. But the most important section and the coolest section, in my opinion, is the findings and flags section here. And the first time I ran this, it actually gave me the criticality of these findings. So there was high, medium, low. This time I just ran it, it actually didn't give me that, which is interesting. So I think I'm going to update the script so that it adds into the prompt that we specifically want that, because I found it was really helpful. But as you can see here, there's 16 different findings, and these could be misconfigurations. These could just be informational things. These are worth looking at. This is what you hand your manager. Or say you just started at a new job and you need to understand the network fast. Run this on day one, run this on week one. You'll have a baseline document before your first team meeting. If this is something you'd actually use at work or that you found useful, hit subscribe. I put out practical content like this for engineers who don't have the time to build things like this themselves, and I want to make your lives easier, let you do things like this faster so that you can work on the things that are really important to you. Now let's talk about what else this thing can do. So the first additional thing that I want to show you is the diagram generator. Again, the default does not generate a diagram. So if you do want a diagram, you have to add this additional flag. It's just dash dash diagram. So we'll run this again. Okay, so that finished, and we will collapse our old one, open our new one. And as you can see here, now we have a draw.io file. The other run, as you can see, there's not one in there. So we'll go ahead and open up draw.io, and we'll just open up that file. And here it is. And as you can see, here's our diagram. And again, this looks very similar to the one from the last video, but most importantly, it's just included in the script and it's automated. Another really cool thing is you can change the AI provider and the model that it runs against. So if you're not a Claude user, you can change it to OpenAI or Gemini, and then you can pick which submodel within those providers to use. So we'll just run the help command and you can quickly see some of the flags that are built into this. It's just --help. And so here you can see we have the provider, Claude, OpenAI, or Gemini. Right now, the default's just set to Claude Sonnet 4.6. So if you don't specify this, it'll just assume that it's using Claude Sonnet 4.6. The GitHub and the blog will explain how to do this a little bit more in detail if you're curious. This matters because your company might only approve one AI vendor, or maybe you already have some OpenAI credits to use. The script doesn't lock you into a specific vendor. You can change vendors, you can change models. So now for the limitations. The limitation that you're going to run into is tokens and context window size. Just due to AI in general and how this is built, depending on the size of your environment, you may run into limits. Now, I'm just running this against a 3-device lab, so there's going to be no issues there. If you have more than 20 devices that you're trying to run this against at the same time, I would recommend splitting it up into batches. So splitting it up into separate network closets, maybe separate your MDF and your IDF per run, and then combine those into one larger document, or just have separate document or separate diagrams per closet and do a little bit of manual work to combine those two. But just real quick here, I'll just show you the tokens used on this. So we ran it twice in our test on screen here, and it used about 70,000 tokens on Claude Sonnet. So it seems to use about 30 to 33,000 tokens per run, which isn't a ton, but it's also not nothing. So just keep that in mind. If you're interested in multi-vendor support or any additional AI vendor or model selections or any other features that you'd like to see, let me know in the comments below, or submit an issue into the GitHub repo and I'll happily take a look and see if I can implement those features for you. As always, the script and examples will be in GitHub along with a README and documentation on what all of the flags do. There's also a help flag that you can use in the script itself that will show you which arguments do what things and how to use them. So here's what we covered. First, we replaced a 5-script manual workflow with a single command pipeline. Second, we set up a YAML inventory file and an API key, so the script runs with 0 copy-paste. Third, we ran one command that runs our script and generates a complete runbook as well as a finding list at the bottom. And lastly, we generated a network diagram with a single flag. Keep in mind, the default when you run this does not include the network diagram flag. So if you want that, you do have to add the -- diagram flag. If you haven't seen the first video in this series that breaks down the 5-script workflow step by step, I recommend checking that out. I'll have a link to that up here. And thank you for watching, and I'll see you in the next one.